Hello guys out there, I hope you had a fantastic half term and ready for your exams and some mathematics. Okay, today guys I'd like you to focus on page 45 to page 49 of your ABC book B. Okay, so the focus is to do parallel lines and perpendicular lines. Okay, so let's look at some few examples before you do your exercise. Okay, I'll look at examples exactly from your ABC. Okay, determine whether the following lines are parallel or not. Okay, so to determine the two lines are parallel, we have to show if the two lines have the same slope. Okay, same slope, that is the gradient also. Okay, so if I look at the two examples, I'm redoing exactly the two example. You have 2x minus y equals 4, and you have 2x plus y equals to 3. Okay, so I have to show that they're parallel. So I have to determine the gradient for that line and the gradient for that line. If the gradient are exactly the same, then I can conclude the two lines parallel. Then if not, then they're not parallel. And for us to determine the gradient for the straight line graph, we have to write in the standard form, and we know the standard form is y equals to mx plus c. And m is the gradient and c is the y-intercept by just looking, given that you've written it in the standard form. So let's do that for our problems now. Okay. So for this, so we remember standard form, we have to solve for y. Okay. So keep minus y this side, I keep minus y this side. Okay. If you look at your ABC, they do it differently, that's okay. I move -2 the other side, -2x plus 4. Okay. Remember, I have to solve for y. I divide by -1 both sides. I'll get y equals to 2x, because negative divided by negative is positive, negative divided by negative positive, positive divided by negative is -4. Therefore, m for this is 2. That's the gradient for that line. The gradient for that straight line graph, it's positive 2. Then now we have to determine the gradient for line 2. So let's do the same. So y, just move 2x the other side, you get that -2 plus 3. It's already in that form now. Then I can happy and say, therefore, my gradient is -2. Okay? Then is -2 the same as +2? No way. Not exactly the same. Then remember to answer your questions. Okay? What is our conclusion? What is our conclusion? Your conclusion is, look at that. The lines are not parallel. Why they're not parallel? They don't have exactly the same gradient, guys. Okay, beautiful. Okay, that's example A. Let's look at example B, exactly from your book again. Okay, example B. So if you look at example B, let me just copy everything again. Exactly from your ABC. If I look at this, you have 2y equal to x and 2x minus 4 equals 2y. Okay, let me rewrite that there. Okay, which is 2y b, where we have 2y equal to x and 2x minus 4 equals to 4y. Okay, beautiful. So we have to write this in the standard form. Is this in the standard form? You ask yourself first. No, it's not in the standard form. For me to determine the gradient, it must be in the standard form. So we divide by 2 there, divide by 2. Then we get that y equals to x over 2. Guys, and x over 2 is the same as what? Half x. The same thing, okay? So what is the gradient for our line 2? M equals to half. Okay, beautiful. What about the second one? Okay, y is already that side. Okay, so I can just I like putting my y on the left hand side. So y equals to 2x minus 4. I don't have to change anything. If a equals to b, therefore b equals to a. Okay. Here I can just divide by 4, divide by 4, divide by 4. Therefore I have y equals to 2 over 4 is half x minus 1. Happy here. Therefore m for this is a half. Therefore guys, you have to conclude the gradient for that line is half, the gradient for that line is half. If the two gradients are exactly the same, then I can conclude. Okay, if you look at your ABC there, your example from your ABC, you have the lines are parallel because they have exactly the same gradient, guys. Okay, good, beautiful. Now let's look at perpendicular, because the line, they might be parallel. Yes, we agree. I mean parallel, there might be parallel equidistance between the two, but we're also interested in perpendicular straight line. Okay, now let's look at how can we determine if the two straight lines are perpendicular. Okay, using our gradient. I'm doing exactly the same examples from your book, from your ABC. We're on page 45 again. Okay, determine. Okay, so if you look at that, okay, if you look at this, if two lines are perpendicular, then the product of their gradient will be equal to -1. Implies that if I multiply the gradient of two straight lines, if I get -1, I can conclude that they're perpendicular. If it's not equal to -1, I cannot conclude perpendicular. Okay, let's look at the two examples. If I look at this, A, let's look at essentially the A from your textbook. So we have A, which is 2x minus y equal to 8, and minus 2x y equal to 5. Beautiful. Okay, so what I can do, move y the other side. Okay, if I move y the other side, I'll get 2x, move y the other side, and move 8 the other side. 2x equals to -8 equals to y. I like writing this properly, where I start with y. Y equals to 2x minus 8. Then what is my gradient? Remember, the gradient is the coefficient of x. Therefore, gradient for line 1. So that 1, guys, okay, look at it from a book. When you say m1 with the 1 there, means the gradient of line 1, okay? m2, the gradient of line 2, okay? So m1, which means the gradient of line 1, m1 equals to 2. Okay, great. Now, let's find the gradient for the line 2, okay? So what I can do, let's see if I've done everything properly. Okay, yes, I can just move 2x that side. Therefore, y equals to 2x plus 5, okay? m2 equals to 2. Are they perpendicular? They're not perpendicular. They're parallel because exactly the same gradient y. So guys, you have to write your conclusion. If you look at your ABC, the lines are not perpendicular. But what I would like you to do, just do this. Say, okay, this is far better. Just say, okay, m1 times m2 is not equal to -1. Therefore, this is okay, not perpendicular. Okay, or you can say not perpendicular. That's fine. Because if I multiply the two gradient, my answer is not going to -1. Therefore, the two lines, they're not perpendicular. Okay, let's look at B. Exactly from your ABC again, if you look at B, we have, let me write that. B, you have 4y equals to 2x, okay? And what? negative 2x minus 7 equals to y. Okay, which is negative 2x minus y equals to minus 7. Sorry, what am I doing? Negative 2x minus 7 equals to y. What am I doing here? Okay, let's look at exactly that. So firstly, so this is from your B. I write the two straight line in a standard form. What is a standard form? You solve for y, okay, with respect to x, okay. So solve for y here. Divide by 4, divide by 4. Therefore, y equals to 2 over 4. What is 2 over 4? It's half x. Then what is the gradient for line 1? M1, which means the gradient for line 1 is half. This side, it's already in a standard form. Minus 2x minus 7y. I mean, that is already in a standard form. That is already in a standard form, okay? If you like, you can just rewrite and say, okay, I prefer y this side. That's okay. Minus 2x minus 7, okay? And you can go ahead and say m2 is negative 2, okay? Then you go ahead, guys, and say, okay, m1 times m2. You check what is m1. M1 is half times m2, which is negative 2. If I multiply the 2, yes, that cancels that. I get negative 1. Therefore, the two lines, they're perpendicular. Two lines, they're perpendicular. If I multiply the two gradients, I get negative 1. If you see there from your ABC also, you can see if you multiply the two guys, you get negative 1. Okay, that's beautiful. Hope you understand, and you try this and work hard until page 49. Okay, so you do the exercise 10. Exercise 10, you start there. Determine whether the following pairs of lines are parallel, perpendicular, or not. Okay, so you write this in a standard form. You can conclude they're parallel, perpendicular, or not. Okay, so you do that. Okay, you do your page 45 until you do your page 47. And page 47, it's exactly the same. Write in the standard form and write your conclusion. Okay, beautiful. Then and go to exercise 2, which is exactly the same concept, but let me do one for you just to show you. Okay, it's exactly the same concept. For now, you can pause, maybe watch this later and do your problems, but let me explain this. Okay, determine P if the following pairs of lines are parallel. Okay, what is the value of P if the two lines are parallel? I mean, the value of P, I know that that and that must be exactly the same for this to be parallel. Therefore, P must be negative 2. Because if P is negative 2, they're parallel. Okay? So, I'd like you guys to try this also. Okay? Good. I'll see you guys on Tuesday when I come back. And enjoy.